Hello, this is Math 2270 coming to you from the College of DuPage for summer of 2020, and this is lecture called Bernoulli's Equation, Conclusion. When I left off with the first part of this lecture, I had posed this problem and asked you to solve it. I'm hoping many of you did, but if not, what I would say is you know what to do. Let's see how you did. Now this time, this is a negative number, and so it is minus 2. We move it to the other side, making this y squared. That means the substitution here is v is equal to 1 minus a minus 2, which is y cubed. We take the derivative, then v prime is this business, and we substitute this into the equation right here. And we do the equation and we get this, which is the same as this, and we can solve this. Now realize that we do have to be concerned about this minus 15. This is plus a negative 15, but that allows us to find the integrating factor, and so the integrating factor is e to the minus 15x. So we multiply all the way through by that, and you should verify all these details. But when you then solve that for v, the resulting linear differential equation, you get this for v. And there's your arbitrary constant sitting there. Now we do a back substitution. That was y cubed. So we get this. We can use our initial conditions way up here and substitute in, and we get that c is 139 over 17. There are no ugly numbers, just like there are no ugly babies. So we have that, and then what we can do is we will change things to, when we'll solve for y, that's a cube root, and we get this expression. If we look at this, we have a 17 in the denominator, so there's no problems with x, so the interval validity is all real numbers, negative infinity to positive infinity. Here's another problem for you to solve. Notice this time that the exponent is 4. You know what to do. Let's see how you did. All right, so we divide all the way through by this y to the 4th, obtaining this, and we do this substitution. That is 1 minus 4 is minus 3. That gives us that. We take the differential, and then we're going to substitute this into this expression. And notice that there's some arithmetic happens here with that. And we have to massage this just a little bit to get it into the form that we want, which is this. But now it's amenable to finding the integrating factor, and it's going to be e to the x. Again, you're verifying all of this work. So we multiply all the way through by e to the x and solve that. And again, this is good practice. And this is what you end up solving for v. Now we can substitute back in for what v was in terms of y. We have this expression. And this is a good time to use my initial condition then to figure out what c has to be. C is minus 5 over 8. And then we turn both sides upside down, take a cube root, and we get this for y. Now, it does require a little bit of thought or calculation. This would not really be a good exam problem talking about finding the interval validity, but it turns out this thing is never 0. So the answer to this for interval validity is negative infinity to positive infinity. Here's another example. Now this time it's not in exactly the form, but if I moved the square root of y to the other side, I'd have an exponent of y as y raised to the 1/2. Again, Bernoulli works for fractions. You know what to do? Let's see how you did. All right, so we move that to the other side. We have this, and then we do our substitution. Here's the substitution that we use. Oh, first of all, we divide it all the way through by the y to the 1/2, getting this. Then we make this substitution for v, and then this is v prime. So we substitute all that in, we get this. Again, we have to deal with the 2, so we deal with the 2. We have that. And so now it's all set up to find the integrating factor. Again, you should validate all this, but the integrating factor is going to be x to the 1/2. So we multiply all the way through and integrate and solve, and we get that v, the solution to the linear first order differential equation, is this. And there's our constant. But now we can substitute for y. So we have this. And you should realize that we have a x to the minus 1/2 here, and that means we have to stay away from 0. So we do have, and I guess it really shows up down here too, we have to stay away from 0. And so the, let's see, and then we use the initial condition. We could do that first, I suppose. We get c is minus 1/3. And then when we solve that, we get this. And we have to stay away from 0. We look at the two possible intervals of validity. And we choose this one because that's where 1 belongs. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of others. God bless.